Okay, we are in software engineering lecture 7. We're talking about DFDs. DFDs are data flow diagrams. In the previous lecture, we saw system analysis in an object-oriented approach using two things: use case diagrams and activity diagrams. Those are both UML. Those are both in the family of UML. DFD, which we're going to learn today, is not in the family of DML of UML. It's much older, in fact. It's probably 40 years old, and it was originally used in business analysis of companies. There was like a person who comes who's a systems analysis person, forget about computers, just comes to a company, and IBM says, we want things to run more quickly, more fluidly. Because there's too many bottlenecks, things are going slow, we don't even know how all the different procedures in our company are working. When somebody wants to order something, how does it go? So they would use data flow diagrams to analyze how a company is working, to try to figure out, first you have to figure out how does it work, and then you can try to improve it. And the way that you can analyze it is follow the information. You heard the expression follow the money. This is the expression follow the information. Follow the information means, if you see that it's information going from this secretary to that secretary, so what is each secretary doing? Why does it go to them? Figure out, ask that secretary, ask that person, and then find until all the information, where does it go and who makes the final report, and that'll tell you something about how the company is working. So we do the same thing with the computer system. We try to figure out how the information is passing. Okay. Nothing to do with the first approach. It's not an object-oriented approach. Okay. So the goal is to provide a detailed characterization of the new information system, that is, to precisely define the execution in the system. So we have these are the different parts of the diagram, like a process, an input, an output, and databases. There's data is stored, because we're talking data, ultimately computers process data. The product of the analysis phase will be the basis of the design. In other words, we'll do this analysis of, see, like I said, originally the idea was to analyze a system that already exists. So you analyze the system and then you computerize it, or you improve it, you remove it. You say there's 3 steps here that I get rid of. But here we're going to analyze the system in our head in order to create we're going to create a system. We're not analyzing an existing system, we're defining how a system should work. But the system will be the basis for its design and implementation of the system. In other words, this design could actually help us design software. We'll define the software components and the functions. Okay. It's graphical. We want to see what the processes that the system performs and all the data that goes in and out between them. It's a static picture. It doesn't necessarily show what happens first. It'll be sometimes it will see things that are first, but sometimes not. But it'll give a picture of possible information flow between activities. There are 2 types of DFDs. We're going to do more like the DeMarco one, which has a hierarchical DFD, which means that they'll be like, you get into more, the idea of hierarchy, it's funny, it's kind of weird, he's explaining everything before showing you one, and it's kind of abstract. But the idea of a hierarchical here, he's giving a mashal, a metaphor for it. It would be like if you would have a world map, and one page would be the whole world, and the next page would be just Australia. The next page, and then the next page would be one part of Australia. The next page would be another part of Australia. Next to another, and then the new page would be North America, and then the next page would be one part of North America. So that's hierarchical, because the first picture you have is the whole world. Then you have a continent. Then you have what's in the continent. Then you have another continent. So it's hierarchical. That's what we mean. That's what we're going to do. There'll be a super diagram which will contain all the continents. Okay. So this is what we mean by hierarchical. Hierarchical means what I just said. We have one diagram that has the whole system in one diagram. And then we break each part of that down into lower levels and lower levels. and becomes more specific. So there's a father for every diagram. It came from a parent diagram, but except for the first one. The first one is the overview. Each diagram has one or more sons, or children, I guess should be called. And they're connected. And here are the elements of the diagram. There can be a circle, or a triangle, or a square. It's like first grade or kindergarten. We have our shapes. Not a square, it's a rectangle. But let's go into the more detail. The circle is a process. And it can be simple or complex. If it's complex, we do two circles. What does it mean complex? A very simple definition. You want complex process means this process will be further analyzed. In other words, there'll be another diagram to explain it. If you have a basic process with one circle, that means that's it. I'm not going to explain it anymore. I've explained it. In other words, if it's simple, it's sometimes called a simple process because it doesn't need more explanation. Like get user login information. It's pretty clear what we're talking about there. But another thing might be like calculate the batting average of, a baseball of the entire team. Let's say calculate the average of the batting averages of all the players. So I mean maybe that's also simple to think about, but maybe there's parts of it that are complicated, and therefore it would be a complex process. And that double circle means that there'll be another table to explain it. There's triangles, which are with a T in the triangle means that it's a time-related triangle. That means at every certain time I do something. At 12 o'clock at night, I reboot all my computers. Or 12 o'clock at night, I do a back all the day. And that's a time. R is a real-time event, which means, like for example. If the smoke detector detects that there's smoke in the room, then the system will turn the sprinklers on and put out the fire. So that's not a timed event. It's an event that was triggered by some kind of sensor, right? Some kind of real-time event. And then there's an arrow which shows the data flow. This is a square. What is a square? Denotes an external entity or system user marked with an E. It's somebody who's using the system. And there's two kinds of things that can use a system: a human being or another system. Another system can interface with our system. And then there's these little triangles, these like more narrow. What do they call it? What's that called? Yes, rectangle with a box on it. That's a database. Okay. So we said the single circle could be called a base process, a basic process, I don't know why. In Hebrew, this is translation. I guess I didn't notice I wrote the same thing twice here. A primitive process. It can also be called like an elementary process. I call it a basic process. Primitive is also a good name because primitive means it's also like a primitive data type. Integer is primitive. All these words appear in professional literature. During the course, we will usually call it a simple or base. They don't even write simple here, or base process. Okay, I gotta fix that. System boundaries. There's also another part of the diagram, which is the boundary, which is that many of these elements, not all of them, but most of these elements are inside the boundary. The boundary is like this, is like a border, like that, exactly like that dark line. The boundary is because it defines everything that is within the information system will be found in the boundary. For example, people who are not part of the information system, even though it's very surprising. That is very surprising because why is it very surprising? Because in UML, in the beginning of the course, the first lecture, we defined that an information system is composed of, and we said like 5 things, and one of them was the people. But they're part of the system, they give information. But it's not part of the SUD, system under design. It's not part of the system under design because we're not designing the people. People already exist. They may be part of the system, but they're not part of the design system. Anyway, the people or the other systems are outside of the bound line. Everything that belongs to the tradition will be outside the line. There's two sides, the left side and the right side, and they're different. The left side is input to the system, and the right side is output from the system, people who get things from the system. So here's finally, wait a second. Yeah, finally we get to see an example. It doesn't much matter what's written here in Hebrew, but I'll explain to you what is going on. Here is the diagram. Notice there's a boundary. You see that? Boundary is this blue line. And then this is called the DFD. This would actually be called DFD 0. Because it's the topmost level. It's before, and then it's the topmost thing. It's 0 level. It's like the whole world. I see now all the continents. And then these circles are different processes. Notice that 4 of them are simple processes and 1 is complex. Usually you won't have it like that. Usually in the DFD 0, most of the processes would be complex because your system needs to be explained. So, but in this one, this the sample here, only 5 would get further explanation. Now, these entities, these E1 and E2, they have to start with the letter E because they're entities. And they are outside of the system, which means that they are either other systems or people. Here's a time entity, which is also outside the system. The timer indicates, oh, it's 12 o'clock. The clock on the wall says 12, so the system will start doing something. Now, over here, we have entities that receive information. Notice the arrow is pointing from the entity to the process. So let's say for an example, the process is create user login. So the information going would be his username, and what you'd write on top of the arrow would be his username. It would be username or user information. You'd write here user information, and then this would be called user, or new user, and this would be called create account, and then this would be a database. Right? That's why it says a D. D stands for database, and we number them to indicate they're different ones. Now, why are there different ones? Really, you should think about the databases as being different tables. It's not like they're duplicate. It's not like a whole database. It doesn't need to be a whole database. It can be even just a table. So this table could be student, a user account information table, right? And this table could be, I don't know if it's a store, or let's say a school, let's say course listings, And then this arrow means that data is transferred from the database to the process number 1. We call that reading or we call it writing? What would you say?
Reading.
Right. And this is called writing. If this database transfers information to the database, there should be no database. It's not allowed to have a database that has only reading. Now this process writes, and this process writes. If there wouldn't be this process that reads, then it would be illegal. You can't just write to the database. It has to be somebody. If you're never reading from it, then there's no point in having it. Right?
Yeah.
At minimum, at the end of the month, you do a report on what's there. Somebody has to be reading from it. That, by the way, interesting way. Let's say you come to IBM, and you find that everybody is filing into this filing cabinet these reports. These, whatever, every sales that occurred, they put into a filing cabinet. And you ask, okay, we went to all the secretaries in the company, all the managers, everybody, and nobody ever looks at that thing. There's never a time in anybody's day that they ever go to that filing cabinet. So you, in your system analysis, you would have determined that these people are writing, and these people are writing, and there's no reader. So what would you advise IBM? Stop keeping track of this. Why are you keeping track of this if nobody's reading it? Or start using it for something. You can justify why you've been keeping it. So there needs to be a reader and a writer. Notice that D1 appears twice. That's because the same table appears twice as allowed, but then we put a little slash here. We put a little slash there to indicate, so you don't get confused and think it's a new database. Also E1 appears here and here. That's allowed also. Because he's also providing data and also at the end of the day getting data. And also E3 appears twice on the right side. That seems strange. Well, the reason why do we do that? That's just because if we would only write it once, we'd have to have an arrow crossing through the diagram and it would get messy. So for clarity, we put E3 twice. Now we don't just write E3, we also write like what his name is. But we have to give them numbers. And then these are data flows. So that's why it's called a data flow diagram. That's basically everything in a nutshell. Here I just say that you can have the same entity on the right and the left. See that, E1? Isn't that beautiful, those hands there? How do we do? How do you create these hierarchical things? So you can do bottom up or top down. Bottom up would mean start with all the lowest level processes, what's going on, and then group them and then group them until eventually you get to the grouping of everybody. The way that I like to do it really is top down, which I start with all the basic elements that I want to have. Especially since in our lab, we already created user stories. So we already know kind of, we already did the bottom part. We already know like the bottom part. Now we need to just say, well, what are the groupings? So that would be top down. Start, the main topics and then subcategorize them. The parent diagram, as I told you, is called DFDFS, DFD0. Now we'll see how you do a lower level. DFD always contains all the complex processes of the information system we want to analyze. Yeah, in other words, everything should be there in a sense. Just like a world map, a one page has all the continents. It doesn't have every city maybe, but it represents every city because every city is somewhere on the world map. Here's an example of a DFD0, where you see that they're all complex systems. And one of them, they usually start with the word management, for example. Management of lecturers, student management, department management, course management, administration employee management. There's no external entities here yet, but the point is, this is your starting. Now, let's say for student management, which is 2, just press 2, we want to explain what goes on in student management. For example, there's registration for courses, there's student payments, student union, I don't know what that means, joining the student union, I don't know. Registration for exams, welfare, whether we get some kind of welfare. All those things happen within 2, and that's what makes it complex. But in other words, we have to ask the question, what can be done with these students? Those are all things that can be done, and that's in student management. What sub-processes are related there? So now we're going to say like this, we're going to take this 2, and we're going to explain what's going on inside. We're going to zoom in on student management, and that's what we let's get something like this. You see this one? DFT2, registration. So here's all the things that happen inside of student management, right? Student management is 2, and that's why this is called DFD2. Because it's not because it's level 2, because it describes what we call 2 in DFD 0. If this, well, let's say 1 would have been without a double circle, then there would be no DFD1. If this would be a single circle, it would mean it's a basic function. There's nothing more to say. So there would be no DFD1. There'd be a DFD2, or it might be a DFD3, but there wouldn't be no DFD1. There would be a DFD0 and then a DFD2. So it's not the numbers just mean which one I related to in the previous one. And that's what we call it hierarchical. Now we have 2.1 now, because 2.1 is like inside of 2. Registration of courses. Where is process 2.1? Why is super complex? Well, because registration of courses is not a simple process. It's complex because it can be broken down. The decomposition will be called DFD 2.1. Which will explain now what happens in process 2.1, which is registration of courses. And we might find checking the registration time, eligibility check for the course. Did you have all prerequisites? Have you paid? Check for collision. Is the course full? Maybe you can't register for it. Does the course overlap with another course he's taking? These are all things that is the actual steps in registering for this course, and that will be in DFD 2.1. Do we have an example? We don't have DFD 2.1, but unfortunately. But where were we? Yeah. But we would now have to write a third DFD called DFD 2.1, which has circles in it. And what would the circles be called? Well, if we wanted to stop there, then we would have a circle called has student passed prerequisites. Has student paid, check, process student paid, student paycheck. Course, is the course full? But if we wanted to go, but we could, and we write all the things that we have to do, all the different procedures, processes that would be not necessary to register. We have to write every single thing. If we wanted to, we could just write check for collision, check eligibility. But then what we'd have to do, if we would write like the red things that are things in red, and that's all we would write, then and that would be DFD 2.1. Then we'd have to write another DFD. We'd have to write DFD 2.11 for checking the registration time, and then explain what that is. And then DFD 2.12 for checking eligibility, and DFD 2.13 for checking for collision. At some point, though, and in each, and then in 2.13, we would write, is the course full? We'd write all the things that we do check over there. So at some point, you got to get to the things that we do. Student payment process can also be complex. It's possible to break it down into student payment check, payment tracking, issue receipt. Okay, for complex process, we will decompose it into at least 3 processes. In other words, you shouldn't have a complex process. It's kind of rule of thumb. It's not called complex if it only does 2 things. Then just make them into 2 separate things. Creating DFD diagrams through the system. Creating a DFD diagram of a given system. DFD diagrams of a given system is done in 2 steps. First, you create the DFD 0, which is called, or also called the root diagram. And then functional decomposition. This is top down. This is if you're doing it top down. I mean, this is not the only way to do it. So if you're doing it top down, then you start with the DFD 0 and then you do functional decomposition. Find the main process, locating other components of the DFD 0, which are the database, external entities, find the information flows. Question: how do you locate the main processes of an information system? Through the organizational structure. Well, that's what I was saying about IBM. If you have, IBM has an HR department. It has a department of sales. So we'll start off in DVD with sales. So one double circle will be HR, one double circle will be sales, one double circle will be development, one double circle will be testing. And those are all different departments. And then you can start saying what each department does. So that's what it's saying. The organizational structure gives you a hint at how the information is flowing. Because usually the information is flowing between, most information is within a particular section. Let's say the HR, most information in HR is within HR. There's also in between HR and other things, but mostly it's within. So you get in one diagram, you can show all the information flowing among the different HR workers and their jobs.
I know.
Financial information system of an organization, the main process could be accounting, these are just examples. Student information system could be student registration, tuition, payment of course, registration, academic tracking. Etc. Personal, another example. Means for identifying. What does it say? Complex or base process. There are no exact rules for determining is a project, is a process complex or basic. In other words, I could say paying tuition is simple, just pay the money. Or I could say, no, paying tuition is complicated. I gotta know, does he have a grant? Does he have a discount? Did he, is he paying by credit card or cash? And that affects maybe is pay more if he pays a credit card, there could be all kinds, like it's complicated. Who's to say? It depends on, you could write a DFD and say, no, that's a simple thing, and that's it, and that's the level of detail I wanna get to. Below are the means, there are three means of identifying, deciding whether the process is based. If the system analysis estimates that what the process does, its logical process can be described in a short verbal description, structured writing, or flow diagram, the process is basic. That is, if I can write a simple flow chart, actually maybe that's enough. Then maybe it's basic. If I can write, a flow chart with, well, this happens, even though it has steps in it and ifs and elses, that could still be considered basic. And I could not have to write that and leave that for a flow chart to later. If I can figure out to break it down, but I can't figure out to break it down into more than 3 subfunctions, we will not mark it as complex, but we will create 2 basic processes. It shouldn't be more than 3, it should be 3 or more. It should be 3 or more. That's gotta be a mistake. Not in the translation, probably, but in the actual thing. If the process is related to many processes, database and external. Yes, if it's using lots of other processes, if it's interacting with lots of things, then it's probably complex. Okay, so when you analyze a complex process, this top-down method, you're going to look for the subprocesses. You find child diagrams, take each child diagram, and you functionally decompose it. And you do this until you get a situation where everything is basic. So you can have a situation like this, DFD at 0, and then DFD 1, 3, and 4 is in DFD 0. I don't know why 2 disappeared. For some reason 2 disappeared, but here, DFD 1 has 3 and 4, and DFD 3 has 3.3. I don't understand actually what this is. It's not always balanced. I guess what they're saying is, I understand what they're saying. They're saying that DFD 0 actually had in it DFD 1, 2, 3, 4, and 5. Why are 2 and 5 not here? In this diagram? This diagram is just showing the complex ones. That's what they mean. So we don't see that DFD 2 is here even though it was there, because it doesn't have any children. And you'll say, well, what about DFD 4? Why is it here? Because it's complex. Now there's in DFD 0. That's an interesting question to ask. That would be a good test question. Given this picture, draw DFD 0. And what would you have to write? You would say, well, I don't know what to write, but you know what to write. You know that you have to write DFD 1 as complex. You know that you have to write DFD 2 because we don't have to skip. So you'd have to write DFD 2 as basic. Because why is it not in this picture? It's not in this picture because it's basic. DFD 3 you'd have to write is complex. And now DFD 4, would you write it as complex or basic?
Basic? No.
Oh, why not? That's my trick question.
Yeah, it's a trick question.
It's a trick question. It's not a trick question. It's a question that requires you to think about it. Why is this? I'm saying it's basic. It's not basic. I'm saying it's complex. A very simple answer. If it would have been basic, it would be like 2, it wouldn't have been here.
Oh, so 2 is basic, that's why it's not even there.
Right. If this would have been basic, it wouldn't be here. It's here because DFD 4 actually is a diagram. There is a diagram called DFD 4, and in it is DFD 4.1, DFD 4.2, and DFD 4.3, and DFD 4.4. But all of those are basic.
So 1.3 is also not.
1.3 is not basic, exactly, it's got parts, it's 1.3 is a diagram which has 1.3.1 and 1.3. And then we have another question asked, in this, is it possible, according to this diagram, must there be DFD? Must there be process, and I'll use the word very carefully. Must there be process 1.3.1?
No.
Again, I got you, you're good at writing trick questions.
Yeah.
It's not a trick question though.
Test.
You're not paying, you're asleep.
No.
Why must there be DFD 1.3.1? Not DFD, process.
Oh,
Process, that's what I said, I'm using the word carefully, process, 1.3.1.
because 1.3 is there, so it needs.
Because 1.3 is what kind of process?
A complex process.
And therefore it must have
A basic process.
parts, must have parts.
Small parts.
And those parts must be minimally 1 point.
1 point, like it has to be 1.3 and then add it to the decimal.
And then
point.
0.1, and now it's point 1 must be there, at least 0.1. Now it's a better question, harder question. What about this? Is process 1.3.1, no, sorry, 1.3.3 there?
1.3.
Is process
1.3.
1.3.3 there?
Not necessarily.
No,
Necessarily.
necessarily, tell me why.
Well, 1.3.
If I would have said 1.3.4, the answer would be not necessarily.
Oh,
But why 1.3.3 is necessary?
1.3 is there? I'm confused.
Because we said twice, there's 2 places in the slides where it says you don't call a process complex if it only has 2 parts. It has to have at least 3 parts. So if 1.3 is complex, it must have 3 parts. So there must be 1.3.3. You see what I'm saying?
Yeah.
Otherwise,
Right.
if there's no 1.3.3, there's just 1.3.1 and 1.3.2, then that's a stupid diagram, it just has 2 circles in it. Every diagram has to have at least 3 circles in it. You understand? So it must be,
So-
yeah.
Is there an example of like what you just said? Like of the other one? Is there
What do you mean?
like
Well-
1.3.2, like where do you see that?
No, I'm just asking a question. Here's the 2, which is 2.1.
Okay.
Now, when I go to diagram DFD 2.1, there's gonna be 2.1.1 in it.
Mhm.
Yeah, there's an example, you know. It is an example. The truth is. No, he doesn't, he took it away, he used to have an example, I can show you an example,
Okay.
after we finish these slides, I'll show you an example, I have an example, I'm pretty sure. Where were we? No. That was a little good exercise, I was just doing to wake you, see if you're paying attention. Wait, we did all this, where are we? Yeah, we did, there's where we were, okay. Data dictionary, you also have data dictionary. The DFD diagram will be accompanied by a data dictionary. The data dictionary will detail the entities, the databases, the processes, the streams of flows. In other words, for example, an entity, I might say, um, maintenance worker, and I might have another entity called support maintenance worker. And I have to explain, what is the difference between the maintenance worker and the support maintenance worker? What things can they do, what that the other one can't do? Because it sounds like, right,
Yeah, it sounds similar.
sounds similar, so I have to have a data dictionary, I have to define, what is that entity? And also the database, I have to explain what's being stored on the database. Data stream is the easiest one to explain. If I have like a thing called create account, and from the user, it says account information is on the arrow. Remember on the arrow, you write what information is being passed? So if you write account information, it's fine, but what is account information? Do I require his age or not? Is that one of the things or not? Maybe I don't care about his age, maybe I do care about his age, or his birthday, let's say. So I have to define what is the stream that I called, I gave it a name, I'll write a name, and then on the other side, I'll write a colon, let's say. And after the colon, I'll write all the elements. The hierarchical diagram approach allows the system to be seen at different levels of detail, right? If I want to see the whole system, I have the DFD 0. I want to go into detail, I know exactly which page I don't even need to get page numbers, I just can skip, I just look at the top of the page, if it's DFD 2.1.3, I know what it's explaining. It allows top-down analysis, it allows the coordinated work of several work teams. Because once I have the main diagram, I can simultaneously work on everything in DFD T2 and everything in and so another group can do DFD 3, and a third group can do DFD 4. For each basic process, we will be asked which data flows enter and which leave it. Right? That's the ultimate, that's why it's called a data flow diagram. We're really interested in what's going in and what's going out. The data flow can come from an entity, from a database. Oh. Right, or from another process. Data streams go out to a process, or can go out to an entity, a process, or another an entity, database, or process. We will identify where information flows from and where they go, and thus we will discover who are the entities and who are the databases. Here we're back to our picture again. This is DFD 0 of some system. And then here is DFD 1 and 3. Why 1 and 3? Why not 2? Why not 2?
Because
Look at this diagram. What's different about 2 than 1 and 3?
well, the 2 isn't circled.
The 2 isn't double circled, right? So therefore,
It's not the end state or the.
yeah, it's not the end state. We call it the basic state. It's or the simple state. It's a process, not state. It's not a simple process. 1 and 3 are complex. Therefore, there's DFD 1 and DFD 3, and there's no DFD 2 because he is a simple process. Nothing more to say about it. And now DFD 1 has 1, 2, 3, and 4. Notice that 1.3 is complex. What does that mean? There's going to be another table about him, another diagram about him, but there won't be a diagram about 1.2. Here's DFD 3. Here's DFD 4 because he was complex. Notice these are all basic. Okay, so there won't be a DFD 4.2. There'll be a process 4.2, but no, here is process 4.2. Okay, rules of the law of information conservation. Every database and external entity related to a complex process will also appear in the child diagram of that process. In other words, if I had, for example, in 4 here, where we're let's say in 1, you see how I see in 1 he's using DFD, he's using D1, right, and D2. You see where I am? So when I go to look at 1, I'm going to see D1 and D2. Wait a second. Question. Why is there no database 4 here? Look, there's database 1, 2, and 3. There's no 4. But look, here it appears. How can that be? Why? We just said everything should appear here. And like we said, we didn't say that. We said everything that appears here should appear in its child. So here this is the child. So 1 and 2 are in fact here. 1 and 2. But where did he come from? Why wasn't he in the DFD 0?
He's from 1.3.
What?
Is it because he's from 1.3?
Explain yourself.
You wanted to. Well, wait, he appears. D4 appears right there.
This is the first appearance of him, look, here's DFD 0, I should see everything, why don't I see everything here, why don't I see DFD, why don't I see database 4?
Because you don't see everything in that diagram. You don't see 1.3.
Why did the designer decide
It's too
not to
complicated.
show it? Why did he choose that one? Don't show DFD, don't show D2.
Well,
What were his rules? What is?
if it's connected to something that's too basic or
Not too, would be too basic.
basic,
You say it's connected to 2 is basic. It isn't, it's connected to something very complicated. 1.4 is complex, 1.3 is complex.
oh, no, because it's connected to like it's too complex or something.
Nothing to do with that.
1.3 and 1.4 aren't in the other picture either,
Yeah, why aren't they?
because they're the child's, like
Yeah, okay, that's
It's not
true.
showing
You're
them.
saying facts,
showing
but
them, it's not showing,
so therefore,
it's only showing the parents right now.
right, okay, and here we do show them. Again, I'm asking my question, why did this database suddenly appear?
Why does it suddenly appear?
Yeah.
Because
Why didn't, or another way, why didn't it appear here?
it wasn't relevant, so like.
Why wasn't it relevant?
It's not going into the detail.
Not expressing yourself, alright, well, I'll tell you what I want you to say. What I want you to say is because this database is being used internally by, how do I get rid of this? It won't go away. Why won't that black thing go away? You know how to get rid of it?
That thing, that now.
Share. Okay, now, okay. This, where were we? This database 4 is completely internal to D1. It is used by D1, by 2 parts of D1, but it's internal. If I would write it here, then I would write that D1 writes to it and D1 reads from it. If I would have written it here, it would be that that 1, sorry, I said that wrong, that 1 writes to it and 1 reads from it. So that means it's internal, nobody else is using it, just 1. So he is inside of the complexity of 1. It's part of the complexity of 1. It has nothing to do with 3 and 4, so therefore I don't put it here. Every database that is here is used by more than 1 process. If it's only used by 1 process, I do not show it. That's the rule. What about D1? Look, D1 is only used by 4. So doesn't that break the rule that I just said?
Yeah,
No, it doesn't. Tell me why it doesn't.
it's also used by one.
Because it's used by 1. This is not the real 1. This is a copy of it. Here's the real 1. And he's used by, so he's actually used by 3 different people. 1, 3, and 4. So that's why he's here. You got it?
Yeah.
But the D4 is only internal to 1. Therefore, he appears only when I go inside and say what are the complexities of D1. I want to of DFD1. I want to know what 1 is doing. Now I all of a sudden appears. I hope he says this somewhere in words. Let's see, does it say that anywhere? And it's so every database and every database and external entity related to a complex process will also appear in the child of that process in that role. In other words, with the relevant child. Fine. In other words, he's just saying that's all he's saying is that if D1 appears here, then it has to appear in the definition of D of 1. If D1 is used by 1, then when I go to 1, I better see it. But you didn't explain this. Okay. An external entity will not appear in the child diagram if it was not related to the complex process in its parent diagram. In other words, if there was an external entity that talked to complex process 2, then when I look at complex process 1, I won't see it. Even though it's an external entity, I won't see it. So what we can actually make another rule. All external entities will appear in DFD 0. Understand why? Because, I mean, there's no reason not to. That's why. Well, I should put them there. They're using something. There's no rule that they have to be used by 2. It is possible to decompose a complex external entity into sub-entities in the child diagram. So, right, an external entity could be complex. Could be, for example, user, and there could be a user who's a member, a user who's a one-time user, a user who's a VIP user, but I could just write user. And then I can explain the different kind. New database will appear for the first time when it is he says it, by at least 2 processes. That's what we said. That was the rule, of which at least one updates it and one reads from it. Data entered into a complex process must, in the decomposition, appear at the entry. The data entered into a complex process must, in the decomposition, appear at the entry of one of the processes derived from the complex process. Right. So to regarding incoming data. Oh. It should be outgoing data. Whatever. In other words, he's saying like this. If there's if I show data coming here from this entity into 3.3, from this entity to 3.3, then when I look at 3.3, there better be a circle there that's getting something from E3, from entity 3. All right, so those are the rules, important rules. More rules. The elements of a DFD are a process, external entity, a database, a time entity, a real-time entity, information flow. Okay, we will learn rules for each of them. Okay, rules for a process, for process component, the rules for the process. I should get rid of this word component. The rules for processes. A process can be basic or complex. Each process in the DFD diagram is given by a unique identifier number. Intended for identification only and not for indicating the order of execution. Each process has an ID number. Therefore, different processes do not receive the same number. Oh, I just thought of another trick question on the exam. I could do I could write like a diagram with circles, and I could write the same number in 2 circles, and then write a slash in the circle. And say, is that legal? And you'll say, yeah, because that's the same rule we had by the databases. Except that we never had that rule by circles. So you know, not me. You're not allowed to do that by circles. You're allowed to do it by databases, but not by circles. You're allowed to repeat, we learned, you're allowed to repeat entities, and you're allowed to repeat databases. We never learned that you're allowed to repeat processes. You can only have a process once. Each process is given a unique number. A complex processes are usually given nouns, and basic processes are given imperative sentences. Right. If it's the basic process, it's like compute average. You know, the more classic one would be deal with everything to do with students. That would be the process. So it's more complex. There will be between 3 and 7 processes in each diagram.
Okay.
Well, because if it's less than 3, then it shouldn't be. Then you shouldn't make it. And if it's more than 7, then it's too complex. It'll be too confusing to the reader. Break it up. The DFD 0, in other words, you gotta break it up in a different way. Reorganize it. You want it to be readable. Be careful not to go into too much detail in DFD, in any given DFD. Right? It has to be, if it's complicated, there's too many parts, then combine them into complex processes and put those in a separate page. Be careful not to go into too much detail in DFD. If we have reached a process that is clear from its name what it does, it should not be broken down any further. Do not make a loop in a process. Exactly. In the same way that you don't have data going from database 1, I mean from process 1 to database 1, and then back to process 1, and that's it. That you'll explain inside. So to here. If this shouldn't exist. Because if DFD, if one is complex, so inside of one, you'll show that 1.3 sends data to 1.4. But you don't show that one sends data to itself. It's irrelevant. When I'm looking at one, I don't care what the internal procedures are. You must not create a pit process. Here's a pit process, like a dead end. Notice that it just goes to process 2, and then process 2 does processing, but there's no output. So I don't care about that processing. That's to tell somebody. If you did a lot of work in your basement and then died, Pastor Shalom, and never gave your work to anybody, then it was worthless. The process has to produce something. See all these little lines here? This is Google translated them for me.
So cool.
It went into the places. I didn't have to highlight them, even though they're separate text areas.
Whoa.
But this shouldn't be first reservoir, it should be first database.
Oh, reservoir.
Reservoir. Each process must have one or more data input and one or more output. Process B has one data, so it's an error. Explanation of the external entity. So that was rules for processes, now rules for external entities. What's the rules here?
Yeah.
Other rules here. They all make sense. Users can be employees of the organization, parties outside the organization, or relationship with the system. The user is not part of the software. He will appear outside the diagram boundary on the right or on the left. If he's depending, right and left have different meanings. Left means input, right means output. A user is not necessarily the operator of the system, but the person. This is that's the point that I think is important. But the person who is the source of the data flowing into the process. The user is the one who needs the systems of systems. In other words, I want to create an account. I'm a student. Now, maybe I am blind and have no hands, and I can't use the system, and I speak to my assistant, and my assistant types in the, or I speak to the Pakida, to the worker there, and she types in the information. So am I going to say that the worker put the information in? No. The blind, no-handed person put in the information, because it's from him. He's the source of information. Doesn't matter that he can't actually do it. Or even in, I don't know why I give that example, it's a kind of graphic example. But let's say, just any situation. Like a student comes, a 10-year-old girl comes to the public library and makes a library card. She doesn't type on the computer, but the information is, the librarian types the information. But she asks her, what's your name? The librarian types, what's your age? Where do you live? All that information is coming from the 10-year-old girl. So she is the user of the system, even though she's on the other side of the desk. So that's what this rule number 4 means. 5, the name of the entity is not the name of the person, but the role or the name of the organizational unit that is assisted by the system. In other words, you don't call it Martha, you call it librarian, or you might call it managing librarian. It's a super librarian. An external entity therefore represents a type of user who provides data to the information system, or for whom the information is transferred to from the system. Therefore, it will be necessary to designate an appropriate interface, an API. An API is a way that one system is a method is defining the rules of engagement between one system and another. If I want information from this system, I have to read their API. It says, oh, you want to get this information, you got to type in this. Right, that information, type in that. So that's an API. It's the rules for how one system can interface with another. Every point of contact, read that again. An external entity could be, for example, a system or a person. Therefore, represents a type of user who provides data to the information system or to whom information is transferred from the system. Therefore, it will be necessary to design appropriate interfaces. Every point of contact between a human user and the system requires an interface. There'll always be an I don't know. Fine, but I don't know. The interface means that there won't be a person. I think what he means like this: there won't be a person on the left or right of the diagram that has no arrow. There'll always be some arrow. An external entity is identified with the letter E and a unique number. Multiple external entities. So you see here, in diagram DFD 0, I wrote 1 and I wrote it as complex. And I wrote that E1 communicates with it. But when I went into 1 and I explained that there's part 1.4 or 1.7, I can explain that actually there's two different kinds of workers, of clients. There's private, what's it called? Wholesale and retail. A wholesale client and a retail client. They use different parts of the system. They're both parts of E1. So this is how I show inheritance. I don't use an arrow. I just by the numbering system. We have VIP customer, different kinds of customers. So that would be a complex. So that would mean that E1 is complex entity. Right? This is a general customer, and this could be like a VIP customer and a regular customer, or retail customer and a wholesale customer. So databases. A database is a storage place for data, accumulated execution of some process, and is estimated that they will be needed for some other process, right? It's storing, A stores it, B gets it. Each database is identified. It could theoretically be that A writes to it and B reads from it. Doesn't have to be another one, because right. Well, in the end, I won't show it though. That's eventually there'll be two different processes. There'll be a process called right. Eventually we'll do this. Each database is identified by letter D, to which a new number is added. When a database is in DFD, when a database is in DFD 0 or in a DFD that is a node in the hierarchy tree, it should be associated with at least one process that updates it and another different process that extracts data. So here you go. 1 is writing, 2 is reading. 1 is writing, is reading. Okay. Writing or updated data is adding, changing, or canceling. That's cancel is also kind of writing. Reading is retrieving from the database, performing a search. Reading data from the storage medium. Updating a database requires searching. Updating a database requires searching for the record we want to update, but there is no need to specify this in a separate process. So if I want to do update, I can just leave it as update. I can call it update. I don't have to say, well, wait a second, in order to update a process, you have to search for it. Yeah, it's understood. We don't have to detail that. Examples of retrieving from a database. Retrieve all relevant jobs for each person who came to the interview. Retrieving the grade of a particular student in a particular course. Examples of writing. Write the address. Calculate each student's grade after giving a factor in a particular exam. In other words, change all the grades by a factor of 5, or not by a factor usually is a multiply, but by an addition of 5, by a bonus of 5. Okay. Now we're talking about database. The database can only be associated with processes. This law applies not only to a buffer, but to every arrow in a DFT. There will always be a process at the end of an arrow. So, for example, this is illegal. An entity cannot directly update a database. And a database can't update a database. When using a database with the same name and the same number more than once, we put that diagonal there. So you're allowed to use it twice. Okay. Database D appears twice, but the second time there's a diagonal. Okay. Further. External database. An external database is a database from another system, like an internet database. An external database for which will be drawn outside the boundary on the left or the right, depending whether we're reading or writing. How do we decide if a database is outside the boundary of the system or inside? Any database that we're not going to be designing. It's not the system under design. It's not the system under design. Then it's outside. An external database is something that I'm not currently building, but our system is using. Time entities. A time entity is intended for performing batch activities. Batch means we do them in a batch at a certain time, like late at night, we do a whole bunch of things. So, an activity is carried out, but not at the user's initiative. As the user, batch just means also that I didn't come and say, because I'm here, do this. It's happening not because of me, just because it's the thing that I do every night. At a predetermined time. A time entity will not appear on the right side, because the time entity will never receive information. Time entity can only give information. The time could be at the end of every day, at the end of every month, for a certain time, at a certain time, the 10th of the month. On my birthday. Explanation of the rules of time entities. When it is a basic process, then the time entity is numbered. For example, T1. On the arrow, we will write what the process will be. We will write when the process will be activated. So we write T. This is here. T basic. We write T, and we write at the end of every day, because we're finally explaining what's actually happening. At the end of every day, do this basic thing. But if it's a complex process, then we know that we're going to have another level beneath us that's going to also have the T and also an arrow, but it's going to go into T point P to process 1.2 or 1.3 or 1.1. So since there'll be another one, we're not going to write when the time is, we're just going to write the string. We're going to write the exact words activation date. We're just going to write, so on DFD 0, anytime that we're pointing to a complex process, we're just going to write the words activation date. And because we know that the lower level, we'll have it again, and there we'll write what is the activation date. Real-time entities. Sometimes the information in the system is associated with special devices whose roles receive or transfer. So a real-time data, unlike a time data, could appear on the right or the left, because they can receive data. They could be sensors. If they could be a sensor. A sensor would probably not receive data, but give data. Something connected to a patient to measure his blood pressure, a fire detector. A real-time entity is also indicated by a triangle, but with the R. A real-time entity can appear on the right or the left, as we said. So here you see a real-time entity on the right and a real-time entity on the left. And what does it say inside there? It says, oh yeah, watering system. This is like a kind of real-time system for watering the ground. Here is going to be some kind of sensor that tells you if the ground is dry. And this is going to be a real-time system which tells the sprinklers to water for 15 minutes or every 18 minutes. This is an irrigation system, an automatic irrigation system. It's going to test the temperature, the moisture in the water. It's going to say what season of the year is it, what is the climate, what kind of soil, what kind of crop. So R1 and R2 are real-time entities. 1, 2, and 3 are basic processes. Indeed, right here we write on the line. We're going to write for the real-time entity. What is the data? It is the moisture level. Here Google didn't go to the picture. Google's limit. It couldn't actually go into the picture and translate for me. So I didn't translate it, but this means the moisture level. That's the information that's coming into this system to decide whether to do this or to do that. As an or relationship. We'll see that later. If there is water, but here there isn't water. Whatever, right? Okay. The rules for data flow for the arrows. Data elements. Data flow, also known as a data channel. I don't know how you spell channel. 1 N or 2?
2 N's.
2 N's?
Hey,
And
yeah.
it's the same way you spell Chanel. With 2 L's?
Wait, let me write it. Yeah, Chanel is 1 N.
Chanel, the perfume,
Yeah.
is 1 N. And 2 N's is a channel. And a canal
Canal
is
with an A.
CANAL.
I think it's
Or 2 N's. CANAL.
CANAL.
CANAL, yeah.
Yeah. Canal, Chanel.
So it's spelled the same, no, oh, but, so it should be with two N's, yeah, I think I
Yeah.
spelled it once, I cut my. I split my odds and I spelled it once with two N's and once with one N.
I think you just look it up.
I could have looked it up, I didn't have the energy. Data flow, so also known as a data Chanel, is represented by an arrow indicating the transfer of data. We said this already. The data appearing above the arrow is called a data element. Each data flow, for each data flow, the data passing through it must appear, except for the data flows that go out and enter. If they go out and enter a database. So what's going to the database, you don't necessarily have to write, but what's going to a process, you have to write what is the flow of data. What data is passing? The data passing through it must appear. In other words, you write on the arrow, student information. At least one of the two ends of the arrow must have a circle or a process. You can't have a database talking to a database. Data flow has a name, which is not necessarily unique. The identification of the data flow is done through using the components at both ends. In other words, since the name is not unique, it could be the name is user information. User information is going from here to there, and many places are going to user information. So we can say user information from, we want to talk about it, we can say from 1.4, user information from 1.4 to 1.3. The identification of data, complex data flow versus basic data flow. A complex data flow is an information flow in which the data is not specified exactly, but the data is given as a title. For this is what I mentioned this before: user information, user details, without specifying which details. The complex information flow will usually appear between two complex processes and an external entity or a data store or an entrance to a complex process. There's also a basic flow, is a data flow in which the flowing information is written in detail, such as ID number, purchase confirmation, and the like. A basic data stream will usually appear between a basic process and an external entity, either a database or at the entrance to a basic process. There is no specific symbol for a complex data flow. In other words, you just read, by reading the words, you can tell that it's complex because it says information. I always give my students a hard time when they make their DFDs. That they give me, I don't like, in general, I don't like these complex data flows. I like to see what is the data. But in DFD 0, I'll have to accept them, because they'll be explained later. Here's a complex data flow, report data, right? Report data, I don't know what the data is, so it's complex. The data the student wants is the course number, the course lecture, the credit, the name of the course given first or second semester, how many hours or what days of the week it is. The details of the fields will appear in one of the tables of the data dictionary. So if I never explain it, then if I never explain it in a lower diagram, then I'll have to write in the data dictionary where report data is of this list. What about double-headed arrows? Double-headed arrow for a basic process is not possible to have. Double-headed arrow can be for a complex process. Why? Why is this not allowed and this allowed? Because this really just means that it's going to eventually be in DFD2, in DFD2, which is over here, there's going to be that 1 is going in and 2 is going out. In other words, we'll eventually see who's reading and who's writing. Remember, you can never have this situation. You can never have this situation. You can never have that the whole book that I'm reading it and I mean, it doesn't matter that it's double-headed. You could have you say, oh, I want to double-headed. I'll draw an arrow from 2 to here, and then an arrow from this database to 2. It's not double-headed arrow. It's really loud. No, it's not allowed. If I'm writing and reading, I need to explain when I'm writing and when I'm reading. So that's going to immediately force 2 to be complex. And I'll have to explain to, and who's reading, when am I reading, when am I writing, what circumstance? You see what I'm saying? I think, otherwise I'll be confused. When do I read, when do I write? Okay. Now, we're at the very end now. There's a concept called a connector. And it took me a while to understand I understood what he meant, but I didn't know this term, and I didn't understand the way he wrote it. It was very confusing, but I figured it out. Let's refer to the following diagram. So we have 2 pointing to 3. The flow is called complex flow. Why is that a complex flow? Because since they're both complex processes, I don't know which part of 2 is talking to which part of 3. So this is going to be complex flow. Suppose process 2.3 talks to 3.7 in there. How would we show the fact that 2.3 activates 3.7? In DFD diagrams, process 2.3 and 3.7 are 2 different DFDs. You see the problem? In other words, in DFD 2, I can't show DFD 3.7. The answer is yes, you can. Look what you do. Here's DFD 2, and you show that this one is talking to an external entity. Obviously, it's not an external entity, it's part of my system. So from the perspective of DFD 2, it is an external entity, even though it's part of my system. And similarly, DFD 3 can have a reference to DFD 2, and this is called a connector. Why is it called a connector? Its purpose is to show the connection or relationship to another diagram. If I'm looking at DFD 3, it's showing me how I relate to diagram 2. So it's called a connector. Whatever. Anyway, you can have this. First case, let's refer. So here we have a case like this. This is where 2 talks to a complex one. So, and given that process 2 activates 3.7, where will the connector be and what will this number be? So it'll be in 2 places actually. In DFD 2, won't I have to explain? I'll have to have an arrow. DFD 2 I'm not going to explain anymore. That's it, he's basic. So there's nothing more to explain. So DFD 2, I'm not ever going to explain DFD 2, so it'll look like this. But in DFD, so in this case, where will it appear? It'll appear in DFD 3. In DFD 3, I'll see 2 coming in from the left. And in this one, I'll see in DFD 2, I'll see a 3 on the right. And that's what I explained here. In case 1, it's on the left, and in case 2, it's on the right. The trigger to run the process. Each process can be triggered by an external entity, or by a time entity, or by both. For example, generate report process can be activated 2 ways: by the time entity, end of the month, or by the regular human entity, manager, who is the input side. In other words, he can say, please produce a report, and he can say, end of the month, produce a report. And in the end, who gets the report? The same guy. So he's on the right and the left. Logic in a DFD diagram. DFD diagrams are essentially a static picture of a data flow. However, it's possible to put some kind of logic there. A data flow relationship between 2 processes indicated that one process follows the other. So in other words, 1 is before 2. Even though really we're just saying that 1 gives information to 2. But doesn't that imply that 2 comes later? Because it can't work unless it got information from 1. But we can mark an or relationship. For example, if we want to say that after 1, either 2 or 3 will happen, then I write an or. But if I want to say after 1, both 2 and 3 happen, the information, essentially, what does it mean? The information travels to both of them. Information travels here just to one of them. Upon completion of process 1, either process 2 or 3 will be activated. Here, both of them will be activated. When we have one process from which more than one stream comes out, and we forgot to specify the relationship, we didn't write and or, then the meaning is and. In other words, if I wouldn't have written anything, it would be and. Or the and is the default. Similarly, I can have going in. this information goes in, or this, in other words, one will happen, he doesn't need the both informations. Either he gets this information and he'll run, or he'll get this information and he'll run. But in this case, one can't run. Process one requires two data streams in order to perform its task. He can't run until he gets both of them. When we have one or more processes that receive, well, when we have one process that receives more than one flow, if no relationship, neither or nor and, is specified, this indicates that it's the or relationship. So going in, the default is or, going out, the default is and. That's it. Hope you enjoyed it.
There's 3 types of diagrams that are referred to two other slides.